Good afternoon, everyone. We are the group 5 and our topic for today is about measurement of angles and directions. Meridians are imaginary lines of longitude on the Earth that extend from the North to the South Pole. A geographical meridian is the half of an imaginary great circle on the Earth's surface, terminated by the North Pole and the South Pole connecting points of equal longitude. The direction of a line is usually defined by the horizontal angle it makes with fixed reference line or direction in surveying. This is done with reference to a meridian which lies in a vertical plane passing through a fixed point of reference and through the observer's position. There are four types of meridians. First is the true meridian. Second is the magnetic meridian, grid meridian, and assumed meridian. Through meridian is a plane passing through a point on the surface of the Earth and containing the Earth's axis of rotation defines the astronomical or true meridian at that point. The direction of true meridian at a survey station is invariable, and any record of true direction taken remains permanent and unchanged regardless of time. Also, it is used for making the boundaries of the land. Second is the magnetic meridian. It is a fixed line of reference which lies parallel with the magnetic lines of force of the Earth. Its direction is defined by a freely suspended magnetic needle of a compass held at the observer's position. Magnetic meridian is not parallel to the true meridians. As a line reference, the magnetic meridian is employed only on rough surveys. Grid meridian is a fixed line of reference parallel to the central meridian of a system of plane rectangular coordinates. The use of grid meridian is applicable only to plane surveys of limited extent. Last type of meridians is assumed meridian. Assumed meridian is an arbitrarily chosen fixed line of reference and usually the direction from a survey station to an adjoining station or some well-defined and permanent point. Also, it is used only on plane surveys and limited extent. There are different kinds of method for establishing or determining meridians. The magnetic meridian can be established by setting up the compass over any convenient point and then sighting a distant object that marks another point on the meridian. Another method for determining true north is by the aid of sun and plumb line. By observing the rising and setting of the sun, we can determine the true north. This method can also be used in determining meridians. Polaris can also be used in determining true north since Polaris is very close to true north and is routinely used for celestial navigation. Another slightly trickier but more accurate way of finding south is to use the Southern Cross and the pointer star from the neighboring constellation Centaurus. An ordinary wristwatch can be used to determine the approximate direction of true north or south. The magnitude of an angle can be expressed in different units, all of which are basically derived from the division of the circumference of a circle. The four principal systems of units are the degree, grad, mil, and radians. The sexagesimal system is used in which circumference of a circle is divided into 360 parts of degree. The angle of 1 degree is defined as the angle which requires 1 to 360 of the rotation needed to obtain one complete revolution. This system is used extensively in surveying practice. The grad is the unit of measure in the centesimal system, and the circumference of a circle is divided into 400 parts. The mil circumference is divided into 6,400 parts called mils, or 1,600 mils is equal to 90 degrees. It is commonly used in military operation as in fire directions or artillery units. And lastly is the radians. It is another measure of angle used frequently for a host of calculation and sometimes referred to the unit of angle. One radian is defined as the angle subtended at the center of a circle by an arc length exactly equal to the radius of the circle. In defining direction, there is always a starting or reference point. True north is the north point of the true meridians and it is symbolized by a star, an asterisk, or the letter TN. Magnetic north is a north point that is established by means of magnetized compass needle when there are no local attraction affecting it. Magnetic north may be located either east or west of true north, and the point is usually symbolized by a half arrowhead or the letter MN. Grid north is a north point which is established by lines on a map which are parallel to a selected central meridian. Grid north may be symbolized by a full arrowhead or the letter GN or Y. Assumed north is used to portray the location of any arbitrarily chosen north point, and it may be symbolized by a small blackened circle or the letter AN. Direction of lines. Defined as the horizontal angles the line makes with an established line of reference. In surveying practice, direction may be defined by means of interior angles, deflection angles, angles to the right, bearing, and azimuth. Angles are computed by means of the relationship to known quantities in a triangle or other geometric figures. Interior angles, the angles between the adjacent line in a closed polygon. When the value of an interior angle is greater than 180 degrees, it is referred to as a reentrant angles. It should be remembered that for any closed polygon, the sum of the interior angle is equal to n minus 2 times 180 degrees, where n is the number of the sides. Exterior angles. Exterior angles are located outside the closed polygon and are referred to as explements interior angles. An explement is the difference between 360 degrees and any one angle. These angles are often measured in a surveying work and used a check, since the sum of the interior and exterior angles at any station or point must equal to 360 degrees. Deflection angles, the angle between a line and the prolongation of the preceding line. It may be turned to the right clockwise or the left counterclockwise, and it is always necessary to append the letter R or L to the numeral value to define the direction in which the angles has been turned. Right deflections are considered to have sign opposite to left deflections. Positive sign is used to refine a deflection angle to the right and the negative sign for deflection angles to the left. Angles to the right. Angle to the right are measured clockwise from the preceding line to the succeeding line. The direction of a line may be described by giving its bearing. The bearing of a line is the acute horizontal angle between the reference median and the line. A quadrant system is used to specify bearings such that a line may fall under one of the following quadrants: northeast, southeast, northwest, and southwest. Each quadrant is numbered from 0 to 90 degrees from either the north or south end of the meridian to the east or west end of the reference parallel or the east-west line. Bearings may also be designated in a different manner when the direction of the line in the same direction as the reference meridian or reference parallel. If the line lies parallel to the meridian and south, it is written due south. If perpendicular to the meridian and east, is written as due east. When bearings are employed to define the direction of lines, it is important to identify the meridian used as reference. True bearings are measured from the local astronomic or true meridian. Forward and back bearings. Using the quadrant system, any line of the surface of the Earth may be defined by two directions which differ from each other by exactly 180 degrees. The direction will depend on which end the time is observed. When the bearing of a line is observed in the direction in which the surface progresses, it is referred to as a forward bearing. If the bearing of the same line is observed in an opposite direction, it is called the back bearing. The azimuth of a line is its direction as given by the angle between the meridian and the line measured in a clockwise direction from either the north or south branch of the meridian. Azimuths are usually preferred over bearing by most surveyors because they are more convenient to work with such in computing traverse data by electronic digital computers. The azimuth of a line may range from 0 to 360 degrees and letters are not required to identify quadrants. In practice, azimuths are generally measured from the north branch of the reference meridian for ordinary. Azimuth may be called true, magnetic, assumed, or grid depending on the reference meridian from which they have been measured. Forward and backward azimuth. Any line established on the Earth's surface has two azimuths, forward azimuth and back azimuth. Depending on which end of the line is considered, this direction differ by 180 degrees from each other since the back azimuth is the exact reverse of the forward azimuth. To determine the back azimuth when the forward azimuth is known, the following rules are used. Rule 1. If the forward azimuth of the line is greater than 180 degree, subtract 180 degree to obtain the back azimuth. Rule number 2. When the forward azimuth of the line is less than 180 degree, add 180 degree to determine the back azimuth. The compass is a hard-held instrument for determining the horizontal direction of a line with reference to the magnetic meridian. It is also constructed to allow magnetized needle to swing freely on a pivot at the center of a graduated circle and point toward magnetic north. The compass box of the instrument has a horizontal circle which is graduated from 0 to 90 degrees in each quadrant. The index mark are placed at the north and south marking on the circle. The line of sight usually is fixed along the index mark on the north graduation of the circle. If the line of sight is turned clockwise or counterclockwise, the magnetic north, the needle remains aligned with the magnetic meridian, but the graduated circle rotated in the same direction of turning true to the corresponding angle. The reading which is given is dependent on the position of the graduated circle. The compass needle is magnetized tempered steel balanced at its center on a jeweled pivot so that it swings freely in horizontal. An arrow is usually marked on the north end of the needle and its south end often has an adjustable small counterweight made of fine wire. Magnetic lines of force on the surface of the Earth influences the direction taken by the compass needle since it is magnetized. Its direction of pointing is used to define the magnetic meridian at a particular locality. Types of compasses. First is the Bronton compass, linsatic compass, surveyor's compass, plain pocket compass, prismatic compass, forester's compass, and transit compass. Bronton compass is one of the most versatile and widely used. It combines the main feature of a prismatic compass, sighting compass, hand level, and clinometer. When used during a surveying operation, the instrument can be mounted on a tripod or Jacob staff. This compass is suitable and sufficiently accurate for preliminary and exploratory surveys, engineering type of surveys, and topographic surveys requiring only low degree of precision. The linsatic compass consists of an aluminum case containing a magnetic dial balanced on a pivot, a hinge cover with a sighting wire, a hinge eyepiece containing a magnifying lens for reading the dial graduations, and a sighting slot for viewing the distant object. The linsatic compass was designed for military use such as in reconnoitering, determining direction, orienting maps, artillery, fire direction control, and other uses where magnetic azimuth are required. Surveyor's compass is popularly used earlier for running limited plane surveys or reasonable accuracy. It is now commonly used for forest surveys, in retracting old land surveys, and in geological explorations. Plain pocket compass. This type of compass is similar to the surveyor's compass, except it has no sight vanes. It is a small hand instrument used for obtaining roughly the bearing of a line. Pocket compasses are used in reconnaissance and exploratory surveys. Prismatic compass. In a prismatic compass, the graduations are found on a rotating card instead of being on the compass box. One of the two main kinds of magnetic compasses, including in the collection for the purpose of measuring magnetic bearings, with the other being the surveyor's compass. The prismatic compass, on the other hand, is often a small instrument which is held in the hand for observing and is therefore employed on the rougher classes of work. Forester compass, another type of pocket compass which is usually made of aluminum or some type of metal which does not affect the free movement and positioning of the magnetic needle. Such a type of compass is best suited for forestry surveys as well as for geological and other similar exploratory surveys. Transit compass. The engineer's transit has a compass box which is similar in construction to the surveyor's compass. It is also used for orienting the transit with a magnetic meridian. Magnetic declination. The Earth's magnetic poles are not the same location as the true geographic poles. They are separated by significant distance. The field slowly changes in general direction over time, and it is slightly affected by the position of the sun and changes in radiation from the sun. The magnetic meridian is not necessarily parallel to the true meridian. At any given time, at any point on the Earth's surface, the true geographic bearing of a freely suspended magnetic needle is called the declination or simply declination. Variation of magnetic declination. Daily variations. It is also called diurnal variation. It is an oscillation of the compass needle through a cycle from its mean position over a 24-hour period. Annual variations. It is another form of periodic swing taken by the magnetic meridian with respect to the true meridian. Secular variation. It is a slow, gradual, but unexplainable shift in the position of the Earth's magnetic meridian over the circular cycle. Irregular variation. It is uncertain in character and cannot be predicted as to amount or occurrence. Isogonic chart. A chart or a map which shows lines connecting points where the magnetic declination of the compass needle is the same at a given time. Use of compass. A navigational instrument for determining directions relative to the Earth's magnetic poles. To obtain the magnetic bearing of a line by means of a compass, the observer set up the instrument at one end of the line. Local attraction. Any deviation of the magnetic needle of a compass from its normal points toward magnetic north. In order to detect local attraction, the forward and backward magnetic bearings of each line are read, usually at its ends. Local attraction is present if the two observed directions differ by more than the normal observational errors. Magnetic dip is a characteristic phenomenon of the compass needle to be attracted downward from the horizontal plane due to the Earth's magnetic lines of force. If viewed in a horizontal projection, the line of force defines the magnetic meridian. In elevation, these lines are inclined downward toward the south in the southern hemisphere. The lines are only horizontal at points about halfway between the magnetic poles, such as near the equator. Compass surveys. The method of compass surveying is one of the most basic and widely practiced method of determining the relative location of points where a high degree of precision is not required. First is traverse. A traverse is a series of lines connecting successive points whose length and direction had been determined from fielding measurement. Traversing, the process of measuring the length and direction of the lines of a traverse for the purpose of locating the position of certain points. Traverse station, any temporary or permanent point of reference over which the instrument is set up. It is usually marked by a peg or a hub-driven flash with the ground and identified by consecutive letters or numbers as the survey's progress. Traverse stations are sometimes called angle points because an angle is usually measured at such stations. Traverse line. Traverse lines are lines connecting traverse station and whose length and directions are determined. Advantage of compass surveys: the instrument used is simple and is more portable and less expensive than transit or theodolite. Speed is required. The bearings of all the lines is a traverse may be determined by occupying only every other stations. The direction of a line can be observed at any point along the line. An error in the observed bearing of one line has no effect in the observed direction of other lines. Survey work is much quicker because the compass does not require an elaborate procedure of setting up and leveling of each stations. Obstacles such as trees and shrubs can be passed readily by offsetting the compass a short distance from the line to be observed. There are two types of compass surveys. First is the open compass traverse. An open compass traverse consists of series of lines of a known length and magnetic bearing which are continuous but not return to the starting point or close upon a point of known position. Second is the closed compass traverse. A closed compass traverse consists of a series of lines of known lengths and magnetic bearing which form a closed loop, or begin and end at points whose position have been fixed by other surveys of a higher position. Adjustment of an open compass traverse. In a compass traverse, there are likely to be discrepancies between the observed forward and back bearings of lines. This may be due to errors of observations or local attractions. Two important steps when adjusting open compass traverse. First is determine which among the traverse line is free from local attraction. Perform the adjustment of successive line by starting from either end of the selected line. An important principle to remember is that at any station, the angle between the forward and back line can be computed from the observed bearing taken from the station, regardless of whether or not the needle is affected. Adjustment of a closed compass traverse. The adjustment of a closed compass traverse is similar to the adjustment of an open compass traverse, except that in closed traverse, the effect of observational errors are considered. Important steps performed during the adjustment. First is computing and adjusting the interior angle. Second is selecting the best line of the line in the traverse which is unaffected by local attraction. And third is adjusting the observed bearing of successive lines. Precision of the compass readings. It must first of all be clearly understood that the compass is not an instrument of precision. When using a magnetic compass, precise work should not be attempted nor expected. A magnetic compass is designed to be used only for ordinary surveys requiring low accuracy and precision. An accurate quantitative statement regarding the accuracy of a compass survey could not be made because of the varying conditions affecting this type of work. Sources of error in compass work. First is bent needle. When a magnetic compass with a bent needle is used, all observed bearing will have a constant error. Either end of the needle will read higher or lower than the correct value. Second is bent pivot. A variable systematic error is introduced when a magnetic compass has a bent pivot. The magnitude of the error will depend upon the direction in which the sight is made. 3. Sluggish needle. When the magnetism of the needle is weak, it tends to lag and move in a sluggish manner. This lag produces a random error since the needle is not likely to come to rest exactly on the magnetic meridian. 4th is plain sight, not vertical. When observing the direction of a line, the line of sight may be steeply inclined if the sight vanes are bent. 5. Error in reading the needle. Usually, the source of most accident error in compass work is due to the inability of the observers to determine exactly the point on the graduated circle where the needle comes to rest. 6. Electrically charged compass box. The glass cover of a compass box becomes silently charged with electricity when its surface is rubbed. It attracts the magnetic needle and causes it to stick. Local attraction. The correction pointing of the magnetic needle toward magnetic north is usually affected by different forms of local attraction, such as power transmission lines, items made of iron or steel, underground or deposit, and etc. 8. Magnetic variation. Systematic error in compass survey are caused by daily, annual, secular, or irregular variation in magnetic declination. Such variations are the sources of the largest and most significant error in compass work. Mistaken in compass work. Reading the wrong end of the magnetic needle, failing to observe the reverse bearings and azimuth of line in the traverse, not releasing the needle completely and not allowing it to swing freely about the pivot. Misreading the quadrant letters when taking a bearing near the cardinal points of the compass. Bearing letters are not changed when using the reverse bearing of a line. Setting off the magnetic declination in the wrong side of the north. Failing to adjust the observed traverse angles prior to calculating bearing or azimuth of traverse line. Mixing or interchanging the recording of azimuth from north and south, magnetic and true bearing clockwise and counterclockwise angles, or forward and back bearings. Selecting a line for referencing arbitrary direction which may be difficult to locate later.